Engineering by Cheney School.
Engineering, the use of science and technology to build and use engines and other machines.
But the dictionary definition doesn't quite cover it all, because there are other parts of engineering, that like bridge building and buildings in general, that aren't mechanical at all. We have some other examples.
Robotics. A robotics engineer is someone who designs robots and robotic systems that help make jobs safer, easier, and more efficient. They will spend most of their time designing plans for robots. They also design the process needed for the robot to function. The time spent in the lab is on small mechanical parts that are components of the larger robot. The time spent in their office is on designing plans and writing papers. Honda engineers have studied on the world's most advanced humanoid robot called ASIMO, an acronym for Advanced Step in Innovative Mobility. It was designed to be a multifunctional mobile assistant. In addition to powerful computers and sophisticated software, ASIMO represents years of research in many scientific fields like mathematics, physics, anatomy, and engineering.
Rockets. To build a rocket, you need thrust to move the rocket. Thrust is the force which moves the rocket through the air. Vehicle, to contain the whole apparatus. The vehicle has to be stiff and lightweight. The rocket would need an exoskeleton to help make it lightweight. Guidance, to control the movement of the rocket. The guidance system has two main roles during the launch of the rocket: to provide the stability for the rocket and to control the rocket during maneuvers. And payload, the carrying capacity of the rocket. The payload can be human, satellite, bomb, an experiment, cargo, or anything. The payload is always at the top of the rocket because when the rocket is propelling itself, it gets rid of unnecessary things, and having the payload at the top helps the fuel get there.
Bridges. Bridges are a part of engineering that involves less mechanics and more physics. An example of this is a suspension bridge. Suspension bridges involve four main parts: the anchorages, which are the heavy parts at the end that hold most of the weight and the tension, and then the two towers, or as many towers as you need, in the middle, depending on how big it is that you have to cross. And then you have the suspenders, which are the lines coming down from the cables that help take some of the tension. And that's a suspension bridge.
Example 4. Cars. In car factories, engineering has come so far and robotics has advanced enough to the stage where humans can program robots to build and customize cars. Henry Ford once said about his Model T car, "You can have it any colour as long as it's black." But now, with the tech and brains of today, that's a whole different story. Since cars are designed to be bigger than they used to and made to do much more, parts tend to be bigger and much more heavier, which makes it hard for humans to assemble them themselves. So how do we build cars now? They might have thought, but this was easily solved by the use of robotics.
Future engineering. There are many ideas of how we could use engineering to help us in the future. One of the main ones for this is self-driving cars, which some people are expecting to be here by 2020. They will only be able to drive on specific roads, and they will still have manual controls, but it's still a step forward for engineering. They are controlled by a sensor on the top, and that takes a 3D image of what's around it and sends it to the computer in the car. This then decides what it should do next, where it is, and what could actually happen to make the best decision for where to go. In the future, we will be able to make much more with help from engineering, and we will be there helping it happen.
Overall, we think engineering is an important part of everyday life and covers many different subjects and aspects of life.